Hello students, today's agenda is to check homework. We'll be doing a warm-up and graphing parabolas, and you will be able to do 11.4. Today students will be able to graph parabolas by plotting points and then understand the transformation that occurred. Okay, for our warm-up, if you can solve for x, so pause the video and take a couple of minutes and then come back. Okay, hopefully you did that already. And so to solve for x in here, what we're going to do is get rid of that square by taking the square root. They cancel, but if you do it to one side, you will do it to the other. And so we get x in here. And anytime you have an equation and you take the square root, then it's always going to be positive and negative. And whatever the answer of that is. And the reason is that when you're taking the square root, we're looking for a number that multiplied times itself 2 times gives me 9. So if I say positive 3, well, 3 times 3 is positive 9. But why do I put the negative 1? Because negative 3 times negative 3, negative times negative is positive, and 3 times 3 is 9. So both of these will be true for that. Okay, having that in mind, let's do the second one. The first thing that you do is to cancel by adding 25 to both sides. That cancels, and now we have similar situation than above. 0 plus 25 is 25. We take the square root of both sides to cancel the square. And so x equals, again, plus minus, and the square root of 25 is 5. Now let's start with our parabola. So we're going to graph y equals x squared. And so what I recommend is to draw a table. For parabolas, you will at least need 5 values. And you always put the vertex in the middle, okay? So for the vertex in here, nothing is being added to anything, so it's going to be 0, 0. And you'll understand that more when we see more with parentheses, okay? But in here, you're not adding to x, or you're not adding to y, so the vertex will be 0, 0. And you're going to find 2 values by adding 2 in here and by subtracting 2 down here. So 0 plus 1 is 1, plus 1 is 2. Minus 1 is negative 1, minus 1 is negative 2. And now we're just going to find the values for y when x is 1, 2, negative 1, and negative 2 using this equation. So y is equals to, and it doesn't matter which one you find first, okay? But I'm going to start with this one right here. So y equals x squared. X is 1, so you're just substituting that in there to the second power, and it means 1 times 1, which is 1. For this one, y is 2 squared, so 2 squared, 2 times 2 is 4, so that's the value for y. And if you had 3 in here, 3 times 3 is 9, so the next value will be 9, okay? Now let's go on the other direction. You're going to substitute x, but because it's negative, we're going to take away the x and put the negative 1. Again, because it's negative, you're going to put it in parentheses, square that, and negative 1 times negative 1 is positive 1. Something that I want you to notice is that these values will look the same, and this should also look the same, okay? So for this one, it's going to be y is equals to negative 2 for x. So substitute the x, negative 2, square that. And negative 2 times negative 2 is positive 4. Again, if you had like a negative 3 in here, it would be y equals negative 3 times negative 3, positive 9, okay? So now we have our points, and let's start graphing. It doesn't matter where you start, but I recommend if you get confused with the graph to start with the vertex, so it's at 0, 0. And then open your, parabolas are always like like 2 arms opening, okay? So 0, 0, then 1, 1, 1, 1 is right there. 2, 4 is right there. And then the one that we did mentally, it would be 3, 9. So 4, 5, 6, 7, 8, 9, around there. And now to the other side of the vertex, negative 1, 1, negative 1, 1. And down here, you can count negative 2, positive 4, and negative 3, positive 9. But you can also just see that it's going to be a reflection because 4, 4, and 9, 9. Okay, so if this point is in this direction, 2 spaces away from the line of symmetry, you can just go 2 spaces to the left. This one is 3, then 3 spaces to the left, right? 3 to the right, then 3 to the left. Or you can just go ahead and continue with this, which is negative 2, positive 4, negative 3, positive 9. Okay, and from there you can just draw your parabola. So you can think of this, since in my original is just y equals x squared, you can think of this as the mother graph if you were doing transformations, okay? For number 2, you have x equals y squared, and you can go about for the graph with plotting points for this one, different directions. And so I'm going to do 2 different ones. One of them is to give value to y, and then that way we can solve for x. The other one is to actually solve for y and then choose values for x from there. Okay, so again, we're going to do our table. Again, because nothing is being added or subtracted, it's going to be 0, 0. And so in here, it is very important that we give the values to y instead of x. And so we're going to add 1 and 1 more, and subtract 1 and subtract 1 more to the y values. And so to find x, it's going to be equals to the y value squared. So in this case, and again, it doesn't matter if I start here or from top down, that's okay. Okay, so x is equals to y squared, so y is 2, square that gives me 4. So that's going to be the value for x, okay, 4. And so for the next one, x is equals to y squared, the y is a 1, so 1 squared equals 1 times 1 is 1. For the next one, x is equals to y squared. Because it's a negative, we're going to put it between parentheses, square that, and negative 1 times negative 1 gives me positive 1. And notice how, again, these are the same. So guess what? These have to be the same as well. For the last one, x is equals to negative 2 squared, which is equals to negative 2 times negative 2 is positive 4. So we now have the points to be graphed, but before I graph them, the other way that you can do this is if you have x equals y squared and you want to give values to x, then what we're going to do is take the square root of y so that we can leave it in terms of y. This cancels, and so y is equals to always, always, always plus minus the square root of x. Okay, and when you create your table, and hopefully this will make sense, but when you create your table, you're going to give values to x, but then you always have 2 possible answers. And I'm just going to start with 0, 0. Let's put it right here. 0, and then 0 for y, right? And let me write it in here, but the y first. Y is equals to plus minus the square root of x, and that comes from our warm-up. That's why I put that warm-up in there. And since we're going to be taking the square root of x, we want to choose values for x that are perfect squares. Perfect square are the answers of multiplying numbers times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Those are perfect squares, and those are the ones that we want to choose in here. And you know what? I think I want to just put 1 more on both directions. Sorry that it's a little squished in there, but I'm going to put 1 in here, 4, 9, and then on the other side, I'm going to put 1 as well, 4, and also 9. And you will see why I decided to put those right now. So what that means is that if I put 1 for x, y is equals to plus minus the square root of 1. Y is equals to plus minus. What is the square root of 1? It's 1. So that means that when I replace the x with 1, the answer for y, right, this is the values that we get as the answer, is going to be either positive 1 or negative 1. And that's why I put 2 for 1 in x. That means that one time the answer will be positive 1, and one time it will be negative 1. Hopefully that makes sense. And as you can see, that's what we got in here. A 1 with a 1 and a 1 with a negative 1. Now for the next one is y is equals to, again, the positive and the negative of the result of substituting the x with that 4, which is plus minus. It means one time is positive, one time is negative. The square root of 4 is 2. Again, y is equals to 2 when x is 4, but y is also negative 2 when x is 4. And the last one, y is equals to plus minus the square root of 9, which is plus minus 3. And once again, that means that when x is 9, the answer can be positive 3, or the answer could be negative 3 for y. Okay, and I don't have that many, but again, look at that. You got, when we did it the other way around, you got 4 for both positive 2 and for negative 2. Positive 2 and negative 2 both have 4. So whichever way you want to do it, if you want to solve for y first and then choose values that are perfect squares for x, you can do that. Or you can just give value to y, which I think it's easier. But I wanted you to understand why we have two different answers on y when we have the same values on x. Okay, let's graph it now. And so we have 4, 2, 4, positive 2. 1, 1, 1, 1 is right there. 0, 0, right there. 1, negative 1, right there. 4, negative 2, it's right there. You can also plot these ones, 9, 3 and 9, negative 3 if you want to. So 1, 2, 3, 4, 3, 6, 9, and positive 3, and also negative 3. Notice how when x is isolated, the mother graph is hugging. The mother graph is hugging the x-axis. And when we had y isolated, then it's hugging the y. Okay, so those are our two mother graphs. The vertex will always be the opposite of x and exactly the way it is in y. So it's going to be positive 3, but for y it stays the same and it's negative 3. Okay, only opposite when we have the parentheses. And this is just, no, with transformation, this means that this will go down and this will go to the right. It's opposite for x, okay? So just have that in mind because that was part of the objective for today. And for the values of x, we're going to add 1 and 1 more and subtract 1. So 3 minus 1 is 2. 2 minus 1 is 1. Okay, so for 5, y is equals to, instead of x, we write 5 minus 3 squared minus 3. And that's 5 minus 3 is 2 squared minus 3. And we don't need the parentheses anymore because this is not a negative. And 2 squared means 2 times 2, which is 4 minus 1. No, minus 3. And 4 minus 3 is 1. So that's my answer for y in there. Okay. For the next one, I'm going to write y is equals to, my girls are having fun. If you hear her screaming, they're having fun. They're not. They're playing with grandma. Okay, so y is equals to, the value of x is 4 minus 3 square minus 3. Y is equals to, 4 minus 3 is 1 square minus 3. 1 square is 1 minus 3. And 1 minus 3 is negative 2. 2 minus 3 square minus 3 equals 2 minus 3 is negative 1. Now because 2 minus 3 is a negative, we put it between parentheses and square that. Minus 3. Negative 1 times negative 1 is positive 1, right? Negative times negative is positive. And minus 3 gives us negative 2. Sorry, I'm just laughing with because I can hear my babies. Okay, and the last one, x is 1, so y is equals to 1 minus 3 squared minus 3. All I did was to substitute the x with these values, okay? And so 1 take away 3 is negative 2 squared minus 3. Negative 2 times negative 2 is positive 4 minus 3, and that gives us positive 1. So y equals 1. Whoops, I didn't write that in pink. It's okay. Now we have our values. And so if you recall, our mother graph was at 0, 0. Our mother graph was a 0, 0, 1, 1, 2, 4, and the same for the other side. So 1, 1, 2, 4, and the same for the other side. So that was our mother graph, okay? Now let's see what happens to this one. We have 3, negative 3, so 3, negative 3 is right there. 4, negative 2, 4, negative 2 is right there. 5, 1, 5, positive 1 is right there. And then on the other side is 2, negative 2, so 1, 2, negative 2 right there. 1, 1 is 1 on x, 1 on x, 1 on y, so my graph is right there. And if you notice, the graph moved 3 spaces to the right, which I should remember because I told you that it's opposite. Oh, what am I doing with this arrow right here? It's going to the opposite side. So what do we have here? When you have negative outside of the parentheses, it just means that it's going to go 3 spaces down on y. And negative 3, in reality, as we have seen in the transformations before, you are going to go opposite when it's inside of parentheses. And it says that it's going to be going 3 spaces to the right on x. Okay, so 1, 2, 3 is right there. So it's the same mother graph, but it just moved. And you can do the transformation on x first and then on y, or y first and then on x. It doesn't really matter. For the next one, x is isolated. So again, we're going to be giving the values to y. Okay, so x, y. And for the vertex, it's going to be the opposite on y. Be careful because this is y. Instead of going down on y, it's going to go up on y. That means that the y will be 3 for my vertex. And for x is outside, so it's going to follow, when it's outside, it just follows the path, but on x, okay? And so that will stay. It's only when it's inside of the parentheses that you change the sign and the direction. Okay, so we're going to give the value to y, and so in here it will be plus 1 will be 4, plus 1 will be 5. Down here it will be 2 and 1. Okay, you subtract 1 and you add 1 each time. Okay, and so let's start finding our values. So x is equals to y minus 3, so 5 minus 3 squared plus 2. 5 minus 3 is 2, because it's positive, I don't need parentheses. Square plus 2. 2 squared is 4, plus 2 gives us 6. And so that's the first value of x. For number 4, x is equals to 4 minus 3 squared plus 2. X is equals 4 minus 3 is 1 squared plus 2. 1 times 1 is 1 plus 2 gives us 3. The next one is 2 for y. We're going to substitute y with a 2. So 2 minus 3 squared plus 2. 2 minus 3 is negative 1. Because it's negative, we put it between parentheses. Plus 2. Negative 1 times negative 1 is positive 1 plus 2. And 1 plus 2 is 3. Notice how we have the same values for x, so these should be the same as well. And now it's going to be x is equals to y is 1 minus 3 squared plus 2. 1 minus 3 is negative 2 squared plus 2. Remember that when we have a positive and a negative, we subtract and leave the greater sign. Negative 2 times negative 2 is 4, positive 4, plus 2, and 4 plus 2 is 6. And I will not be solving it the other way, but if you wanted to, all you have to do is just isolate y. Okay, I'm going to isolate it for you, and you can, if you want, you can try to graph it that way. But what you do is subtract 2 from both sides. You get x minus 2 equals y minus 3 squared. Then you take the square root of both sides, and you get y minus 3 equals plus minus the square root of x minus 2. Then you're going to cancel the 3, and y will be equals to 3 plus minus the square root of x minus 2. Okay, so then you can find, because you're taking the square root of something, you're going to find perfect squares and add 2, so that when you subtract these 2, you continue to stay with perfect squares. If you want to try it, go ahead. But remember that from the 3, you will be adding that for one of the answers, and then you subtract that from the other answers. If you want to try it, go ahead. If you would like me to do another video explaining it, leave that in the comments below. For now, we'll just plot this one. So for the mother graph, if you remember, so for the mother graph, we had 4, 2, 1, 1, 0, 0, which is right here. So it was originally like this. Okay, that was the mother graph. Now let's see what happens in here with our new graph. First one is 6, 5, so 6, and then 5 is right here. 3, 4, 3, 4 is right here. 2, 3, 2, 3 is right here. 3, 2, 3, and 6, 1 is 3, 6, 1 right there. Okay, so our new graph, it's right here. Again, notice how it goes the opposite on y, it goes up 3 spaces, and 2 to the right, 1, 2. That's my vertex right there. It moved 3 spaces. Or each point, actually, each point you can count 3 up and 2 to the right, and you will see that we get our new transformed graph. Okay, for number 5, again, we're going to do our, if we wanted to do directly our transformation, it just tells me that my quadratic equation, which is like this, it just moves 1 space up. Okay, so the mother graph was like this, and then 2, 4, and then -2 and +4. So all you would have to do is basically just move your each point 1 space up. This was going 1 up, 1 up, and that's it if you wanted to do the transformation. Okay, again, we're going to be doing that, and that'll be all. But let's do the by plotting points. In here, our vertex will be a 0. When it's outside of the parentheses, that's going to stay the same. Only when it's inside of the parentheses, you do the opposite. Okay, and so add 1, add another 1, subtract 1, and subtract 1 more. And so if we substitute, y is equals to x squared is 2 squared plus 1. 2 times 2 is 4 plus 1, which gives us 5. For the next one, y is equals to 1 squared, right? We are just substituting the y value, plus 1. 1 times 1 is 1, plus 1 equals 2. My English is giving in. Okay, for the next one, y is equals to -1 square. So -1, because it's negative, we put it in parentheses, square that, plus 1. -1 times -1 is +1, plus 1, that's 2. Yay! And y is equals to -2 for x, so -2 square plus 1. -2 times -2 is +4 plus 1, which gives us 5. And again, remember that they have to, because they're symmetric, okay? So they have to look the same. And so 2, 5, 2, 5 is right there. So 1, 2, 1, 2, 3, 4, 5 is right there. 1, 2, 1, 2 is right there. 0, 1, 0, 1 is right there. -1, +2, so -1, +2 right there. And then -2, +5. And then -2, +5, -2, +5. 2, 3, 4, 5, right there. See? So every single point went up 1 space compared to the mother graph. Okay. The vertex will be in the middle. And again, because x is isolated, we'll give the values to y. And so in here, we're adding 1, but again, this goes with x, okay? Why? Because the constant always goes with the isolated variable. On the top, the +1 was in relation to y, so that's why it went up. And for this one, it's going to the right because it's related to x. Okay, so 1 on x, the way it is, if it's outside of the parentheses, the way it is. Nothing is being subtracted or added to y, so that's going to be 0. Again, we're going to be giving values to y, so +1 is 1, +1 is 2, and then below is going to be -1 and -2. And we start solving. X is equals to y squared, so 2 squared plus 1, which is equals to 4 plus 1, and 4 plus 1 is 5. Okay, so 5 right there. And the next one, x is equals to y squared, so 1 squared plus 1. 1 times 1 is 1 plus 1 equals 2. And the next one, x is equals to -1 squared plus 1. x is equals to -1 times -1 is 1 plus 1 equals 2. Okay, notice how that's the same. And then the next one, x is equals to y squared. So -2 squared plus 1. -2 times -2 is +4 plus 1, which gives us 5. There you go. So now we're ready to graph. And again, our mother graph for when x is isolated. Those are the points. Our mother graph, if you remember when x is isolated. So 1, 0, it's just moving one space to the right. See? Instead of 0, 0, it's 1, 0. 2, 1, it's 2, 1. And 2, -1. Let's do that one too. 2, -1. And then finally 5, 2. 5, 2, and 5, -2. So the same for the other side. So the entire graph just moved one space to the right. Yeah, because the original was at 0, 0, then 1, 1, and 1, -1. 4, 1, 2, 3, 4, 2, and 4, -2. And notice how each one just moved one space to the right. Okay, so before we say goodbye, if you can please give us a thumbs up, subscribe around here. You can check out the entire playlist around here. This is the next video in the playlist in this unit. Thank you so much for your support and see you in the next one. Have fun.